Hello everyone, welcome to this video. In this video we'll be learning about order of an element of a group. So what is the order of an element? In the previous video we have studied about the order of group itself. So it was the number of element a particular group contain, that is the order of group. Now what about the order of element of a group? So the order of an element G, suppose we are talking about the group capital G here and we are taking small g as one of the element of this group, then the smallest positive integer n would be called the order of an element G whenever we have g to the power n as the identity of the group. So that means what we are saying, we are multiplying this g n times so that we obtain the identity of this group whenever we have the operation of multiplication. And if we have the operation of addition, it would be equal to adding g n times, and that would give us e. So whatever is this n here and whatever is this n here, that is the order of an element, right? And if whichever operation you have, you can just take it to be like this. You have g star with g star as many times as n. If that give you identity, then this n would be the order of an element, and beware that this n should be smallest positive integer of the kind. So that means after 2n also, after repeating it again also, you would get identity, but you have to take the smallest positive integer n such that when you apply when you multiply it or add it n times, you get the identity of the group. Correct? So whenever we have an integer such that whenever no such integer exists, we say G has infinite order in that case, and we denote the order of an element by writing the same element G under the two straight lines. So this represents the order of an element of a group. So let's see for a few examples here. The first example is, before moving on to examples, let's see what is the process by which we can calculate the order of the group. So in order to calculate the order of the group element, what we do, if we are given multiplication as the operation, then what we do, we calculate the products. The product g, the product g square, g cube, g power 4 and so on, until at some point after calculating say g7, if we obtain e as the identity, then this 7 would be your order, right? So we keep on doing like this until we reach the identity for the first time. So whatever is the exponent if we are multiplying all the numbers, or whatever is the coefficient if we are adding the numbers, then that would be the order of the group. That smallest integer would be the order of the group. So for the implementation here, let's consider this example. Suppose we take this U15 as the group. Now what is this group here? Here the operation is multiplication modulo 15, and this is a multiplicative group under multiplication modulo 15. So that means all the integers which are less than 15 would be included in it such that they are relatively prime to 15. So you see 1 is relatively prime to 15, 2, 4, 7, 8, 11, 13, 14, all are relatively prime to 15. So this is a group, we all know that. Now this group has 8 elements within it, so therefore the order of the group here is 8. Now notice that I'm talking about the group order, that is 8. Now for the order of each of the elements, we have to calculate it 8 times for each of these individual elements. So let's compute it first for the element 7. So if we consider the element 7 here, we wanted to calculate what is the order of this element 7. So how do we proceed? We have to keep in mind what is the given operation. The given operation is multiplication modulo 15. So that is 7 mod 15, and when you calculate 7 mod 15, it is just 7. So it is basically not equal to the identity, which in this case, the identity in this case is 1, right? So this is not equal to 1. So this is not the order. This does not provide us with the order. Here the power power of 7 is 1. So that means we are just taking 7. So if we take 7 square, because here the operation is multiplication, so we are taking 7 multiplied with 7. So it is 49, and we have to consider this 49 under modulo 15, right? So under modulo 15, this is equal to 4, and which is not again equal to the identity of the group. In a similar fashion, you can calculate 7 cube mod 15. So 7 cube you know is 343, and 343 mod 15, I have written the calculation here. You can see 13 is the answer, so here it is 13, and it is not equal to 1. Similarly, for 7 to the power 4 mod 15, we first calculate what is 7 to the power 4, and then we calculate 2401 mod 15. So you see 1 is the remainder in this case. So here you have this as the identity element. So therefore the order of 7 element is this power, that is equal to 4. So we obtain the order of one element here, that is 7 in the group. Let's compute it for other elements as well. So for 7 we are done. For let's see what is there for 11, right? What is the order of the element 11 in this group? For 11 we know 11 power 1 mod 5 is just 11, right? 11 power 2 is 121, 121 mod 5 is 1, right, according to this calculation here. So therefore the order of the element 11 here is 2, because when you take the power 2 you obtain the identity here, right? So the order of 11 is 2. Moving further, what is the order of 14? So here again, so we have done with 11, now we are looking for this 14. So for this 14, what is the order? We take 14 power 1 mod 15, that is 14 only. 14 power 2 mod 15. Now calculating 14 square, 14 cube, 14 power 4, that would be quite difficult, and it would be lengthy. It would involve lengthier calculation. So what we can do instead is we can make use of this mod property. So you can write 14 mod 15 as either 14, or you could write this as 14 is equal to minus 1 mod 15. Now what is this notation tell us? It tells us that when we this is the answer here, this is the remainder here. So when we add 1 to it, right, we will obtain 0. So when we add 1 to 14, when we add minus 1 to 1 mod 15, so we will have 15 here, this is equal to 0 mod 15. So you see, when you divide 15 by 15, you have the 0 as the remainder. So we are taking it to the negative side. So using this expression here, we can now write that in order to calculate this 14 square mod 15, we may write 14 is equal to minus 1 mod 15, and then we can square both sides. So 14 square is equal to minus 1 square mod 15, and minus 1 is just 1. So you see the answer in this case 14 square mod 15, that is equal to 1 here. So therefore the order of the element 14 is equal to 2, right? So similarly we can calculate for the order of 13. Why we are writing all of them in this form? It is because it involves easier calculation, so we are making use of mod. So again we can write 13 as minus 2 mod 15. Why? Because when you add 2 to 13, so here also you are adding 2, so that both sides become equal, and you have 15 is equal to 0 mod 15. So this is how the calculations proceed. So we have this expression. Now we wanted to see what is 13 square. 13 square is minus 2 square. Minus 2 square is 4. 4 mod 15 is 4, which is not equal to identity. Again 13 cube is minus 2 cube, that is minus 8, and minus 8 mod 15 is minus 8 only, which is again not equal to identity, right? What is 13 power 4? That is minus 2 power 4, that is 16, and 16 mod 15 is equal to 1. So you here this is equal to identity. So here the order of the element 13 here is equal to 4. In a similar way we can calculate it for each of the elements here. So what is the order of the element 8 here? Now the trick won't work here for 8. Why? Because for 8 you have to write it minus 7 mod 15, and calculation of minus 7 or 8 is just the similar. So we can leave this concept or trick here, and we can proceed in simple manner. So it would be 8 to the power 1 mod 15, that is 8 only. 8 square mod 15 is 64 mod 15, which is 4, right? 8 cube mod 15 is 512 mod 15, and 512 mod 15 is 2. You can calculate it. And then 8 power 4 mod 15 is 4094 mod 15, which is equal to 1. So the order of the element 8 here is equal to 4, because for the power 4 we have the identity in this case. Similar is for the order of element 4. For the element 4 we have 4 power 1 mod 15, that is equal to 4. 4 square mod 15, that is 16 mod 15, which is equal to 1. Thus the order of 4 is equal to 1, right? What about the element 2? For the element 2 we have 2 power 1 mod 15 as equal to 2, right? 2 square mod 15 is 4 mod 15, which is again 4. 2 cube is 8. 8 mod 15 is 8. 2 power 4 is 16, and 16 mod 15 is 1. So this is the identity. So that means the order of 2 here is this 4, right? And what about the element 1? So here 1 mod 15 is equal to 1. So that means the power 1 here give you this as the identity. So that means the order of the element 1 is equal to 1 only, right? Well, that is it for this video. In the next video, we'll be looking at more examples relating to the order of an element. Thank you for watching.